Hi guys, welcome back to lesson 3 for my Algebra 8-7 students or 7th graders in Saxon Algebra 8-7. We're working out of this book, which is the second edition. So second edition, lesson 3. Before we begin, let me just tell you, I just took my dogs for a walk and they're laying here panting. So if in the background you're hearing some dogs panting, it's really loud and I'm not really sure what to do to get them to stop. So bonus dog picture. There's a golden retriever number 1, that's Scout. Golden retriever number 2 is over there, Boris. He's half golden retriever, half black lab. Anyway, my apologies, kids. Sorry about that. All right, so we're gonna talk today about lesson 3. And what we're doing here is we are talking about fact families, which I talked about in the last lesson a little bit. However, there's something more to that, all right? So for solving equations, I love these guys. I love teaching it this way, right? So looking at lesson 3, missing sum, missing addendum. Okay, so for example, we have this problem. You and I know how to solve this problem. 2 + 3 is 5, right? However, when we talked about fact families in the last lesson, you can take those two, these are called addendums. You can take those guys and you can flip them around, right? So we're allowed to multiply in any gosh darn order. You remember that? Cumulative property, right? Okay, so that means that this is also 3 + 2 = n. And guys, the inverse operation, or the opposite, of addition is subtraction. So if we add in, I moved my camera a little bit, sorry about that. If we add in this direction, we subtract in this direction, which means n minus 3 is 2. If we add in this direction, we can subtract in that direction. So n minus 2 is 3. All right, seems pretty easy, right? So this gets to be more helpful when we get some bigger problems. All right, so let's try example number 1. We are given n plus 53 is 75. Well, sometimes we need to write the other addition fact, and sometimes we need to switch it to our subtraction facts. So until you get the hang of this, it's gonna take a little bit of effort. So we know that this, I'm gonna put my 1 over here, we know that addition can be rewritten as this, 53 plus n is 75, right? Cumulative property, we're allowed to flip them back and forth. If we add in this direction, that means we subtract in that direction, which means 75 minus 53 is n. If we add in this direction, we subtract in that direction, which means 75 minus n is 53. So now here we have our 4 fact families. We have our 2 addition, we have our 2 subtraction. Of all these 4 fact families, this one's gonna be the easiest one for us to solve. So I'm gonna put a little n equals here, okay? 5 minus 3 is 2, 7 minus 5 is 2. So we have 22. Now, this is the original problem way back up here, right? What you can do is double check your work, and I highly advise in all these types of problems, double check your work. So this is what n was, so I'm gonna plug 22 for n, because we said n equals 22. Does 2 + 3 = 5? Yep. Does 2 + 5 = 7? Yep, we did this problem correctly. Okay. All right, so looking at example 2. Oh, that was A, I'm sorry. For B, we have 26 plus A equals 61. If we add, let's switch it around. So our addition, we can do A plus 26 is 61. Now, if we add in this direction, we can subtract in that direction, which makes it 61 minus A is 26. Okay, if we add in this direction, we can subtract in this direction, which means 61 minus 26 equals A. Out of our 4 facts that we have here, the one that will help us the most is gonna be this guy right here, right? So I'm gonna rewrite it vertically, it's written horizontally right now, so that I can do the math here. 1 minus 6, I need to borrow. So this is gonna be 5, that's gonna be 11. We're gonna do 5, 11 minus 6 is 5, 5 minus 2 is 3. So A equals 35. Let's go back up to that original problem and see. 26 plus A, but instead of A, we're gonna write 35 is 61. Sure enough, 6 plus 5 is 11, carry the 1. 2 plus 3 is 5, plus 1 more is 6. We sure did do this right. Good. Okay, so let's check the next one. Oh, now we're going to do it as in subtraction. Okay, so subtraction, we got to be a little more careful because we can't use that cumulative property, right? So for example A, we have, and I'm looking on page 14 down at the bottom if you're following along in the book. All right, so P minus 24 is 17. This is where you can ask yourself the other, so if we subtract in this direction, we add in this direction. So that's going to be 17 plus 24 is P. And there you have it. We don't have to do all 4 facts. You may want to in order to find the correct one, but you don't really need to do all 4 facts. So 17 plus 24, we can go ahead and just do that. So I'm going to write P equals 7 plus 4 is 11. 2 plus 1 plus 1 is 4. So P equals 41. Let's test our test our answer. Here's the original problem here. So instead of P, I'm going to write 41 minus and then 24, and it should equal 17. 1 minus 4, I need to borrow, so I'm going to call that 3. Put a 1 here. Sure enough, 11 minus 4 is 7. 3 minus 2 is 1. So yep, we did it all correctly. Okay. Good work. Good work. All right, I'm going to move my light here. Maybe that'll help keep this in focus. Oh, and then I put the whiteboard right back into it. Oh, okay. All right, so, oh, and then B is 32 minus X equals 14. So let's try this guy. I think it's easier to rewrite it as a vertical problem. So let's do that. Okay, write it as a vertical problem instead. All right, so what we know is that if you subtract in this direction, you can add in this direction. And we do that, we get 14 plus X is 32. That doesn't really help us, does it? Using that associative property, let's do X plus 14. Actually, I'm gonna move that down, sorry. So instead of 14 plus X, we're gonna do X plus 14 is 32. If we add in this direction, we can subtract in that direction. 32 minus 14 is X, and that's what we need to be able to solve this. 2 minus 4, we gotta borrow, right? So we get 8 and 1, X equals 18. Let's go back and check our work. This is the original problem. 32 minus, and instead of X, we're gonna put 18 is 14. Let's double check. 2 minus 18, we need to borrow, so we're gonna make that 2, and this 12. 12 minus 8 sure is 4, and 2 minus 1 is 1. All right, good work. All right, so we can also do this with multiplication and division, guys, just like we've done for these ones. So for example 3, we have 12 times n is 168. Now remember, just like addition, we can use that cumulative process for our property, for our multiplication. So what we have is n times 12 is 168. Well, neither of those really help us out. But if we multiply in that direction, we can divide in this direction, okay? So that means 168 divided by 12 equals n. Well, there we go, we have it, right? We don't even need to do this one over here. In this format, it's a little bit harder to work, so we're gonna take this right here and put it under the table. Use our divisor right here. 12 goes into 16 one time without going over. 1 times 12 is 12. Subtract, and every time we subtract, we bring down. 12 goes into 48 4 times. 4 times. So our answer here is 14. So we come back up here and we do 12. The original problem is this one. So we do 12 times, and instead of n, we're going to put 14, right? Is 168. And sure enough, that's the case. Let's do some side work here so you can see that. This times this is 8. This times this is 4. Do our 0. This times this is 2. This times this is 1. Add those all up. We get 168. 168. And sure enough, that's what we needed, right? So that's how we can flip those all back around, back and forth, right? Let's do B. 7K equals 105. This here, I meant to talk about this before too. I did talk about how multiplication can be shown by a couple different symbols. We can do this, right? We can do this, right? And we can do this. Now this one you won't see as frequently because that looks like a variable, and a variable is just a letter that we're using instead of a number. So like this is our variable here. However, mathematicians, let me just tell you, mathematicians, we are lazy. So we don't want to write something down if we don't have to. In order for us to do 7 times k, we don't even need to put that dot there. We can just say it's this. So the operation going on here is multiplication. Of course, we can't do that with numbers because if I said 1 times 2, how do I know that that's 1 times 2 or 12, right? So if you do just numbers, you got to use one of these guys in here, not this one. We're going to start getting rid of that. You got to use one of these things in here, okay? But if you have a variable, it's like this. So what we're saying is 7 times k, and just for right now, we'll make it a little easier. 7 times k is 105. Now remember, multiplication commutative property goes both ways, right? So k, let me give you some more room here. All right, k times 7 is 105. Just like addition and subtraction, our inverse operation, or the opposite of multiplication, is division. So if I multiply in this direction, I can divide in that direction, which gives me 105 divided by k equals 7. Well, that doesn't really help me so far. Multiply in this direction, divide in that direction. So I get 105 divided by 7 equals k. There we go, bingo, that's the one we need. So we're gonna do 105 divided by 7. 7 goes into 10 one time without going over. 1 times 7 is 7. 3, and when we subtract, we bring down. 7 goes into 35 5 times. So what we're saying here is k equals 15. Let's go back and double check our work. Come all the way back up here to this original problem. 7 times 15 equals 105. And when you're double checking your work, you can put a little question mark here. Just say, hey, I'm just checking, making sure everything's good. So 15 times 7 is 5 times 7 is 35. Carry this, we get 105, and that's what we needed, 105. Good work. All right, so, 4C. 2 times 3A equals 30. 2 times 3A equals 30. Okay, so in this case, what we can do are, we have a couple of options that we can do here, but I think the easiest one is going to be, what this is really saying, remember I said that operation right here is multiplication? So what we're really saying is 2 times 3 times A, okay? 2 times 3. What's 2 times 3? 6, right? So really what this problem is 6 times A equals 30, okay? Well, if we multiply in that direction, we can divide in this direction. We end up with 30 divided by A equals 6. Now, 6A is the same as A times 6 equals 30. If we multiply in that direction, we divide in this direction, we get 30 divided by 6 equals A. That's the one that we need. 30 divided by 6 is 5. So we know that A equals 5. Let's come back up here and test our original problem. 2 times 3 times, and I need to put a symbol here when I'm plugging in for A. I either have to put like a dot or parentheses or whatever, because if I just did it like this, you would think it's 2 times 35, right? So we gotta throw something in there, even though it's not in the original problem. Okay, so we get times 5 equals 30. Sure enough, 2 times 3 is 6. 6 times 5 equals 30. And this is us checking, so I throw a little question mark here. 30 equals 30. We did it right, guys. Good job. Okay, so, and then our last examples here are so I'm on page 16, example 4A. So we have A divided by 3 equals 15. A divided by 3 is 15. If we divide in this direction, we can multiply in that direction, right? Let's see if that helps us. 15 times 3 equals A. That sure does help us. 5 times 3 is 15, carry the 1. 3 times 1 is 3, plus 1 more is 5. So A equals 45. Let's double check our work. So instead of A, we're going to plug in 45 divided by 3 equals 15. And is that true? Sure is. 15 equals 15. Check. We did it. Excellent. Let's try another one. 4B. 64 divided by b equals 4. 64 divided by b equals 4. Okay, on this guy here, we have 64 divided by b equals 4. Remember, this fraction bar is the same as that division. Good, if we divide in this direction, we can multiply in this direction. I hope I didn't say subtract earlier. 4 times b is 64. Well, that's not going to help us, but we know multiplication. We can flip those around. b times 4 equals 64. That's not going to help us either, but if we multiply in this direction, let's divide in that direction. So 64 divided by 4 equals b. There we go. That's what we needed. I'm going to do a little side work here. So 4, and this comes first, so it goes under the table. 4 goes into 6 one time. 1 times 4 is 4. We subtract, and every time we subtract, we bring down. 6 times 4 is 24, and we have no remainders. So 64 divided by 4 equals 16. Now, let's go back up and check our original problem. 64, and I'm not, instead of the fraction, I'm going to do divided by, instead of b, I'm going to do 16 equals 4. And sure enough, 64 divided by 16, sure enough does equal 4. So I'm putting my little question mark here, and bam, yes, that works. All right, give those problem sets a try. If you have any questions about it, bring them up in class. Otherwise, that should be it for this lesson, guys. Thank you so much for your hard work. I look forward to seeing you.